This video is part of our magic series where we show tricks that are spellbinding. So here we have, sometimes when we're trying to rearrange formulas, I'll give you an example. Say it's QR squared. You're required to prove that QR squared is equal to RP times TQ. And you can feel at a little bit of a loss of where do I start with this? If you see squares, like I've said here, my brain buzzes straight away to, it could just be good old-fashioned Pythagoras, so I would be looking to see were there any 90-degree triangles. It could also be that I need to rearrange a fraction like we did in the last video. And so that's what I'm going to try to do here. I'm going to take one of the QRs down to the bottom, and I'm going to leave either of these. So let's leave the RP here, and I'll take the TQ down. And in our last video, we said once you've rearranged the fractions, then you're allowed to look across. So that would spell the letters of a triangle QRP. And if I looked across at the bottom, that would spell the letters of TQR. And now I can look in my picture and see, oh, okay, these are the two triangles that I'm trying to prove similar. And I can head out on that route to prove them similar. Once I've got them similar, I can do the ratio fractions and one step away to go back. So this is very helpful just to let you know, where am I actually heading? Where am I trying to prove things similar? Let's give you another insane example. And so say you've done the hard yards and you've proved that these two triangles are similar. A lot of people would just be happy with that. The reasons, angle, angle, angle. I would say I always like to just turn it into the ratio fractions. First two over the first two, the last two over the last two. The order is really, really important when you write your triangles, so make sure that you're matching up the correct sides with sides based on where the angles are. And so I end up with something like that. Now, in this question that I'm making up, this is what they asked us to work out, and this is why it's part of the magic series. You can look at something like this and think, where on earth am I going to get this? Because if I do rearrange this as a habit, so it would be something like TR over PB equals SQ over BM. If I look across, already I can't do it because there's a four-sided triangle which doesn't exist. The bottom could have worked out, PBM. If I look down, that doesn't work. Four-sided, this doesn't work, four-sided. So it's all just gone a bit south on us. But the most important thing in similarity and proportionality, this section, what I tell my students is, as you get to this section, anytime that you notice lines are equal, just very subtly at the top right of your page, just put the lines that were equal. So maybe these were, you might have had two radii, and you thought nothing of it. You might have had a chord that was the same. You thought nothing of it. You got two tangents meeting at a point. Those two lines are equal. Anytime you find lines that are equal, just write them at the top right-hand side of your page and just leave it there to marinate. Because then when I get to a question and I'm feeling a little bit stuck and I can look at what they're wanting me to prove, but I look at what I have, and in some ways it can be helpful just to almost tick what you've got. So I need TR, that's over there. I need a BM, that's over there. I need a PB, that's over there. And then SQs come completely left field out of nowhere. So to me, it's a strong case for using these two fractions, because I've got three of the things that I need. And then because I've been disciplined and diligent and I've written which lines were equal, I see that RA is equal to SQ right from the beginning. And so in my next step here, I could just say RA equals SQ equal chords or radii, whatever the reason is. And so I can replace that RA with SQ. And so I'm writing out this ratio fraction. And if I rearrange it, the BM is going to go up. So here we have it. The PB is going to go up to the SQ. There we have it. And we've proved this initially confusing equation that they wanted. So I hope that's very helpful for you, just to remember this trick of beginning questions by writing which lines are equal at the top and realizing that they can be interchangeable, especially when you get stuck with a four-sided non-existent triangle. If you did find this Magic Series video helpful, please like it, subscribe to our channel, and share it with your friends.